Are you managing data services across hundreds of Kubernetes clusters, multiple AWS accounts, and on premise environments? If you do, then you also know that it's a nightmare. Application developers want self service provisioning, just declare a database and bind it to their apps. That's all they want. But traditional tools like Crossplane break down when you are dealing with hundreds of tenants, thousands of clusters, and compliance requirements like SOC 2, HIPAA, or FedRAMP. So, how do you orchestrate data services at scale without any overhead? That's exactly what we are going to talk about today with Julian Fischer, CEO and founder of Anynines. Julian, it's great to have you back on the show.
Great to be back. Thank you for having me.
Julian, you have been working on Any9 Hub for a while. Give us an update. Where does the project stand today?
The foundation of anynines Hub is Klutch, the open source project. We've been working with a couple of organizations over the past years to verify the core assumptions of Klutch and to see how data service orchestration is addressed these days. And we've confirmed that Klutch fills an important gap in initial encounters with organizations. For example, we've seen that Crossplane as means to reconcile non-Kubernetes resources from Kubernetes has gotten a lot of traction. Some clients actually doubted that Klutch would be necessary and tried to build a client and a centralized control plane for data service orchestration, both with Crossplane alone. And interestingly, that didn't work well, especially in cases where there are a lot of data service instances to be managed, a lot of service bindings to be managed, a lot of databases, in other words, and where there are a lot of tenants and a lot of Kubernetes clusters. And one problem in particular was that if you have a marketplace that comprises a lot of data services, like different databases, for example, and you want to expose them across a wide range of application clusters, where application developers get that self-service that you would know if you were a Cloud Foundry user, like create a service instance, create a service binding, where you create a database and bind an app to that database, just by declaring your intent. So that is what Klutch is doing as well. And in Crossplane, it turns out that building such a client and then installing that client that exposes such a marketplace to application developers, providing that self-service we want, is quite resource consuming. So it is very important that the custom resource definitions that you introduce to represent those different databases and database instances consequently, that this is done in a very resource efficient manner. So how to do that? In Klutch, we have abstractions. In Klutch, the Klutch connector is lightweight and it can be applied to hundreds of Kubernetes clusters without causing significant overhead. So that's a major learning that it has proven that our value hypothesis actually works out, and that there's enough differentiation from Crossplane, which we use, for example, on the control plane to write integrations, is a sound differentiation. Now, on the control plane side, we've also gathered on the Klutch, on the level of Klutch, interesting insights. For one, Crossplane is a sound technology to write backend integrations. However, it shouldn't be the only one. So in Klutch, we have written our own native operators to integrate automation backends where Crossplane just gets in the way. It is a very particular thing, and the latest major upgrade also forces you to upgrade all your integrations, which is kind of a dependency that, especially if you're looking at a large set of integrations, can be problematic. So having something more native, especially with vibe coding being a thing now, where you can write Go code easier than before, the utility of such an integration technology is changing. It's still there. And another technology showing up on the radar is CRO, the Kubernetes Resource Orchestrator. So writing integrations with Crow and Klutch is also interesting.
That's fascinating. You mentioned seeing traction for Clutch increasing. Can you walk us through the specific business cases you are focusing on right now?
So that's basically the fundamental learnings. We now see traction for Klutch increasing, and among those organizations we talk to, we also been asked to help customers build solutions based on Klutch. And there are two major business cases that currently are in our focus. And one is what we call anynines Hub for on-prem, and the other is anynines Hub for AWS. So at the core of anynines Hub is always Klutch. So it allows you to go and integrate Kubernetes. But we also started to develop a Klutch service broker that allows you to integrate any service that you have integrated with Klutch and expose it in a Cloud Foundry environment of your choice. So write one integration for Klutch and get your integration for Kubernetes and Cloud Foundry for free is the direction we're headed. So in the case of anynines Hub for on-prem, as the name suggests, you are in an on-premise scenario. Data privacy is important. And I mean, if you don't live under a rock and you are in Europe, you'd know that digital sovereignty became a major political goal these days. So there's a higher pressure in maintaining this sovereignty, which also means on-premise becomes more important than it used to be. So in those scenarios, often customers these days have either OpenStack or VMware with a strong tendency towards OpenStack. So with such an environment, the combination of the anynines data services for on-demand database provisioning and Klutch makes up a complete solution for data service orchestration for both Kubernetes and Cloud Foundry. So, and that's a strong business case, and it's something where we see traction. One of the challenges in this case is especially about networking. So if you have a Cloud Foundry in your own network, you have the data services with all the service instances in one network, and you have your Kubernetes clusters, and they have their own networks. How do you expose a data service that is a virtual machine in the Kubernetes network? And we have added what we call the anynines network connector in Klutch. It's using the network connector interface, and it provides an implementation where all the services that integrate with Klutch can be exposed to your Kubernetes application cluster seamlessly. So it's a VM, no problem. It's a container, no problem. So it's basically becoming a full-fledged orchestration framework.
So that covers the on-premise scenario. What about organizations that have already committed to hyperscalers like AWS? How does Klutch fit there?
There's another school of thought, so to say, and those are the ones who have already tied with hyperscalers deeply and continue to do so. So in the global market, the Amazon all-in or Azure all-in or GCP all-in or AliCloud all-in strategies, they are still very popular, and that market is globally seen even bigger than the on-prem market. I mean, that's no surprise. And so we actually don't see the that's quite interesting. We don't see that Kubernetes, for example, has a very tight integration with other Amazon tools. I mean, you can have a network integration, you can have RDS instances and so on, but creating those RDS instances declaratively, allowing developers that local on-demand self-service, just writing a Kubernetes YAML, applying it, and there's your RDS instance ready to be consumed for your app. It's just not there. So we've seen that there's a huge demand for having EKS clusters and then, addressing data service automation using AWS data services for that matter in an elegant way. Well, people started to use Crossplane again. Install Crossplane to your local EKS cluster and address RDS, and that works. However, if you're looking at larger enterprises where platform teams build, developer experiences, and in the end you have hundreds or thousands of Kubernetes clusters, this system breaks down. You need to have a central control plane then. And again, the application clusters need lightweight extensions to expose data service automation. And we are back in the Klutch territory. So in the Anynines Hub for AWS, we actually take this approach, and we have seen a recurring pattern here. So most of the large enterprises are using the well-architected framework. And with that, there come best practices on how you use Amazon accounts, for example, to separate larger tenants in your organization. There's a particular way on how EKS clusters are kept in one account and how data service instances like RDS or S3 buckets or whatnot are located in other special service accounts, where that's an AWS account where all the service instances go. And you repeat that pair of AWS accounts per tenant. So in the end, you're looking at hundreds of AWS accounts, and people would love to create RDS instances from those Kubernetes clusters spanning those AWS accounts, while the platform team needs to maintain an overview on where has been used what. And as long as you use only RDS instances or only AWS resources, AWS billing can be used, to tag your stuff and, get some billing information. But when you start to expose internally developed services or, other enterprise databases, the central policy and central governance breaks down. So this is where Klutch becomes very important. So we postulate that per region, one Klutch control plane is installed. It uses lightweight extensions in the application clusters, and it can orchestrate the creation of service instances such as RDS across a lot of AWS accounts. So we introduced a tenant notion into the latest version of Klutch and Anynines Hub. So you can declare such a tenant. It becomes aware of the AWS accounts that go with that tenant. And that when a user from an EKS cluster provisions a service, Klutch knows it, delegates it back, assumes roles of that tenant, and creates the service instance where it belongs. While the control, the central control for the platform team is given, and they can always ask, hey, tell me, where are the application clusters and what data service instances does this particular application cluster use? And then clients are free to use open source Klutch that's always part of Anynines Hub and integrate their own backends and expose them across all those application clusters as well. So we are really focused on making that fly. It's in the making for a while. We provide automation integration with RDS and S3 for now. Others are to follow, which means you install Klutch, you install your application cluster, a plugin from Klutch, and you can right away create service instances as if you were on Cloud Foundry. Well, just natively with Kubernetes means. So things come together. And we see as a target that we aim to serve medium-sized or small-sized clients with a couple of Kubernetes clusters, but also enterprises with hundreds or thousands of clusters. If you want to use Amazon services exclusively, there you go. You want to use the AWS, your own services or Anynines data service, just add them to the mix. It's a modular framework. And so that's basically, in a nutshell, what has been happening at Anynines.
Let's talk about the technical architecture behind Klutch. How does it plug into existing workflows? Because you're not talking about greenfield deployments here. Teams already have systems in place.
Well, in the end, it's just a couple of CRDs you install in the application cluster. Most people would, assume there's a Helm chart or there's you can integrate it using Customize and your favorite CI/CD pipeline. So installing the Klutch extension to an application cluster is quite simple. We also assume that most of the organizations have ways of provisioning their EKS clusters or their Kubernetes clusters, and installing the Klutch extension is simple. For the anynines hub control plane and the Klutch control plane, you just need a Kubernetes cluster that's somehow managed or maintained. You install Klutch there, and there you go. So for anynines data service, we ship the Klutch integrations already. For Amazon Web Services, the most popular ones, we ship integrations already. If you have already, let's say, a lot of RDS instances, we are working on migration scripts that help you to read the structure. And as long as it is within those best practices, like say you're using the well-architected framework, we're basically able to slurp in, reflect on the existing Amazon topology and read it and create and generate the metadata and import this into Anynines Hub. This is currently in the making, but we have first feasibility studies undertaken, and it looks very promising.
How does Anynine Hub fit into the broader platform engineering movement, especially for teams managing multi-cloud or hybrid cloud environments?
Well, it provides you a uniform layer on of declaring the intent to have this database and to bind an application to a database. So, whether you're creating an RDS Postgres or an Anynines Postgres, for the application developer, there might be slight differences in the spec, but the way you approach this is exactly the same. So you could take an application that runs on-prem and uses Anynines Postgres. You can use Anynines Postgres on AWS if you want to too, because, the Anynines data services are infrastructure agnostic. So in this case, you have a multi-cloud user experience for application developer that's entirely 100% seamless. However, if you are infrastructure all in and you're using Azure data services on Azure and Amazon services on Amazon, well, obviously you invite a certain heterogeneity to your platform. But for example, a Postgres database is more or less a Postgres database. And because we have abstractions for Postgres in Klutch and in Anynines Hub, the difference for the application developer will be minor. But if you're, for example, a big fan of Dynamo on AWS, well, then on Azure, of course, you have to find a corresponding service, that does a similar trick. But that's, a fundamental choice, developers made earlier, and that Klutch cannot be a relief unless they've chosen a service that's inherently infrastructure agnostic, such as the Anynines data services. Yeah.
What kind of real-world use cases are you seeing, or would you like to see, where Klutch extensions are delivering value that organizations haven't experienced before?
Well, again, that's basically what I've been talking about. The Anynines Hub for AWS is a real-world use case. We have seen many organizations that use the well-architected framework. Initially, we had a bit of different topology in mind. We wanted to centralize all data service instances in one account. But these organizations get so big, they can't do that because they run into infrastructure bottlenecks. They have to create multiple different deployments and therefore scatter their usage across AWS accounts. So we had to become multi-AWS account aware. And that's basically what Anynines Hub for AWS is the reflection of that real-world use case. It's compatible with the well-architected framework from AWS. A lot of enterprises use it, and we have a tool to make that a pleasure.
Looking ahead, where do you see the Anynine platform evolving, especially as enterprises deal with AI workloads and increasing cloud complexity? You mentioned data sovereignty and AI sovereignty becoming critical. How does that shape your roadmap?
Well, first of all, I think it's becoming a complete set. Anynines Cloud Foundry is still strong, which means if you want to run a large number of AI agents, and 12-factor compliant apps, there's no better way to run them as running them in a Cloud Foundry. The economy of scale is just awesome. Cloud Foundry is a thing. It remains a thing. We're still growing with our Cloud Foundry business. Cloud Foundry is important. Now, but it's not everything. It doesn't cover all of it. Kubernetes is unavoidable. And why would you? It's a wonderful technology. However, you're basically with a vanilla Kubernetes, you're just left alone in the dark. So with Anynines Hub, you solve the data service orchestration problem seamlessly between Cloud Foundry and Kubernetes. You integrate with Klutch once, and you expose any service to both Cloud Foundry and Kubernetes across those many Kubernetes clusters. That makes the tooling you need to build a real application developer platform with both Cloud Foundry and Kubernetes, or only Kubernetes if you want to, or only Cloud Foundry if you want to. It's modular, and it can be, just used in a flexible way. And I think AI needs a runtime. If you run code, that runs in the cloud, it needs to run somewhere, and it either runs in Cloud Foundry or it runs in Kubernetes, in my opinion. And if it carries state, it needs data services. And if you have data services, they need to be orchestrated. So I think we are building the foundation that is necessary for AI to thrive.
Julian, the work you're doing with Klutch and anynines, especially around multi-cloud data service orchestration and making Kubernetes developer-friendly at scale, is solving real problems for platform teams. Thanks for joining me and sharing these insights. And as usual, I look forward to chat with you again. Thank you.
Yeah, thank you for listening. It's always great to share with you. See you next time in Amsterdam, I guess. And have fun until then.
And for those watching, if you're facing similar challenges with data service orchestration across Kubernetes or Cloud Foundry, make sure to check out Anynines and its solutions. And don't forget to subscribe, like this video, and share it with your team. Thanks for watching.